Hey, you cool cats and kittens. We're going to take a look at some of the multiple choice questions that you chose for me yesterday. I got most of you responded in one way or another, and I I don't think it would be a good idea to answer every question because almost every question was pointed out by at least someone. I count maybe 5 or 6 questions that nobody asked about. So I chose, let's see, I think I've got the 9 most frequently asked questions. And so I can take a look at those. If you really desperately would like to see a different question worked out, certainly get a hold of me. I can always do that tomorrow. And then also to point out, if you didn't notice already, that the document that you access to see these questions at the end of it is the answer key. So if all you're looking for is did I do this question right, the answers are all at the end of the document, including the free response questions. I will point out that I do realize that we are doing multiple choice non-calculator questions in this part, and the actual AP test itself will be free response calculator not prohibited. So I get it that this maybe isn't what our focus is going to be moving forward toward the AP test, but I also think it's valuable for us to look at these types of questions and to think about some of the skills that we haven't looked at for a while. So that being said, I'm going to keep that in mind. These are non-calculator questions. It's sometimes tempting to reach for a calculator to do some of these problems, but we will avoid that. I'm going to start with question number 7. This is a logistic differential equation. It does not tell us that it's a logistic differential equation, but we are one quick manipulation away from that. If I factor 1,000 out of this expression, I get this, which is in our standard logistic differential equation form. And I don't know how else we would do this problem. I guess plugging in values and seeing uh, where the second derivative was negative or something like that. But this is a case where recognition of the logistic differential equation form is really nice because once I have it in this form, I know that my carrying capacity is 1,000. I know that it's going to increase between 0 and 1,000, but increasing at a decreasing rate means, oh, I don't want that arrow on the end of there, means that as we've seen with these logistic growth problems, we've got a graph that looks like this, and we're looking at this section of the graph where it's increasing but at a decreasing rate. And we also saw that that point of inflection happens at half of the carrying capacity. So between 500 and 1,000, which is our carrying capacity, my answer on this one is C. The next question to look at is number 10. A few people asked about this one. And this looks to me like a U substitution integral, just a different way of asking about something like that. It's not just what is the antiderivative, but it's more evaluating it and then solving for the value of k. But the integral itself is a pretty straightforward U substitution. Let U be the denominator. Du is a multiple of the numerator, and so we end up off by a factor of 1/2. The way that I recommend you do these is to also change your limits of integration. This was x equals 0, and so u is going to be 0 squared plus 4. This was x equals k, and so the new u value is k squared plus 4. Pretty simple antiderivative. I just left the 1/2 on the outside. I would say don't worry or don't forget about the absolute value, but in this case, because I've got all positive values, it really doesn't matter. If you didn't remember the absolute value, we'd be all right. In fact, I dropped it after a while because I realized that everything was positive. And then the rest of this is just algebra, a little bit of manipulation with the logs, and how comfortable you are with logs is going to change how many steps this is going to take. I stretch this one out a little bit because I also believe that there's probably a little bit of rustiness with some of our logarithmic manipulations, but there's some stuff we could have done up here if we remember about log of this minus log of that and dealing with properties. About the only property that I used was at this point to bring that 2 up to the top and say that 2 times the natural log of 4 is the natural log of 4 squared, and then solving that. Although admittedly, this is a multiple choice question. Once you get to this point, you could just start plugging in numbers and see what works. Although I guess without a calculator, that's not going to help you too much if you don't know your log properties. So I guess study up on those log properties. But my answer is D, as in domination. Next one I want to look at is number 11. Actually, this was one of the more frequently requested problems, which I found to be interesting. A lot of the Taylor series questions were not being asked about. I think at this point we're burned out on them, but a lot of people did ask about this one, so it's worth us looking at. This is similar actually to one of the questions that was one of the optional questions on the test that you guys just got done taking on Friday. The one where it asks you for the 100th derivative. The technique that I use for something like this is to recognize that these terms of the Taylor polynomial, this is the general form. The third power term is the third derivative at the point where it's centered, f triple prime of a over 3 factorial equals x minus a to the third power. And that corresponds with this term from the Taylor series that we're looking at, the one that is to the third power. And so if I recognize that, the x minus 4 to the third power is the same for both of them, which means what's left, 1 over 512, must be equal to the third derivative over 3 factorial. And then solving for the third derivative is just an algebraic manipulation. Multiply both sides by 3 factorial, which is 6, and then a little bit of simplification. This is the type of simplification that is reasonable and expected for you guys to do on a non-calculator version of a test or a quiz, or the AP test, sorry. Knowing that both of these are even numbers, and so you can reduce it by a factor of 2. But 3 over 256 is my answer for that one. That is D as in Dalmatian. Number 5, this is a good one for us to talk about. I hadn't anticipated, I hadn't seen this one as a big problem, but a lot of people requested it, and I'm actually really glad that they did, because I'm actually going to skip ahead and take a look at this. This equation is one that we definitely want to reemphasize. This will not be the last time we see this one before the AP test. It goes like this. I have the value of the function at one point, and I want to find the value of the function at a different point, and I have the rate of change for the time in between those. And this was a key phrase. I'm sure I said this multiple times as we were talking about integrals. The integral of a rate of change gives us the amount of change. So how much this function changes between time equals a and time equals b is given by this integral. So here's where it was at time a. This is how much it changes between a and b, and this is how much it is after the change has happened. And so for something like this, where they give me how much or what the value of this function is at time equals 0, they want to know the value of this function at time equals 5, and I'm given a rate function between 0 and 5. This is what I'm thinking. The value at 5 is the value at 0 plus the integral of the rate of change. How much will it change between time equals 0 and time equals 5? And so 20 plus this integral. Now, we don't know what this function is. So the value of this integral, we're going to have to do this as an approximation, which is why they've given us these different possibilities. Well, I know that it's positive everywhere, and I'm going to go like this. I'm going to say that it's at least a height of 2. So I know that the value of this has to be at least 10. The area of this rectangle is 10, and that's definitely an underestimate because there's part of this region that's lying above it. So it must be at least 20 plus 10, which means I can rule out all 3 of these. And then I can also say that it must be less than a height of 4 on that same interval. And so the value of this integral, the integral that we're looking at here, must be less than 4 times 5, less than 20. And so this must be less than 20. 20 plus 20 would give us 40, but 40 is going to be a little bit too big. So it looks like my answer is D, as in dromedary. We'll go with that. Boy, when in doubt, go with D. Have they all been D so far? Oh, the first one was C, as in crowet. Number 14 was one of the, well, it was tied as the most requested question. And truthfully, honestly, if I saw a question like this on a test, especially a timed test, I would probably use this shortcut that if I'm looking at this limit as x is going to infinity, this +1 and +3 really don't matter. And then you could probably simplify it a little bit more. But as your teacher, I feel like we should probably talk about a more concrete way of doing this one. And this one feels like L'Hopital to me. The limit as x goes to infinity, the numerator and denominator are both going to infinity, so L'Hopital does apply. So I do it. When we apply L'Hopital to a derivative of logs, we end up with these fractions. So between here and here, this is not an application of L'Hopital. This is me just rearranging and multiplying by the reciprocal of the denominator and distributing some things. At that point, the logs are gone. And so I suppose at this point, we could apply rules that we've learned about the degree of the numerator is the same as the degree of the denominator. And so it's the leading coefficients divided, or the ratio of the leading coefficients. I chose to do L'Hopital's rule a couple more times to get to an answer of 1/2. And so my answer to this one is B, as in Brontosaurus. Number 8, let's see, when I saw this for population between 0 and 100, I initially thought this might be another logistic problem, but then I saw the form of this. They want an antiderivative of this expression, and there may be an easier way to do this one, but the way that I decided to do this was to factor the denominator and then make this into a partial fraction decomposition problem. And so, well, this is what it looks like when I break it apart. To solve this, I get a common denominator, multiply this term by 100 minus p over 100 minus p, multiply this term by p over p, and then, well, solve this using techniques that we talked about. Plug in values of p that give you 0 for these terms. By the way, if this makes you uncomfortable and you'd rather use an x just because you're more comfortable with x's, by all means, go ahead and do that. That's not a big deal. It did not make me uncomfortable, so I kept going as it was. I thought I had done this wrong initially because it's not often that you get the same value for both A and B, but I did, which also makes me wonder if there was maybe an easier way to do this, but I couldn't think of another easier way to do it, so I just kept going. This gives us this thing. Initially, again, I thought about maybe factoring out the 1 over 100, but I also peeked over here and looked at the form of my possibilities, and I thought I might as well just keep those 1 over 100s because that feels like what we are heading in the direction of. Took my antiderivatives. Don't forget about the negative here. You're taking an antiderivative of something with the minus p, so you got a -1 that comes from the antiderivative, and they're going to catch you if you miss out on that. So watch out for that. I had the plus c initially. They're asking us for an antiderivative, not necessarily the specific antiderivative, so the plus c didn't matter. And the answer that I got was A, as in aardvark. A couple more for us to look at. 17 was the other question that was asked the most frequently by several of you, multiple of you, half a dozen or so of you. And I really like this question as there's an easy way and a hard way. I'm sure you could do a L'Hopital version of this or something like that, but the honest intention of this question is for you to recognize that this is the derivative. This is the derivative of the inverse sine evaluated at A. And if you recognize that, you can do what I did and say that the derivative of the inverse sine is 1 over the square root of 1 minus the number. And so since this expression is the derivative of the inverse sine, I wrote down the derivative of the inverse sine, I set it equal to 2, and then it's just a little bit of algebra away from solving for the value of a. I'll just leave that there for a second so you can digest that, or pause the video if you want to take the time and look at the algebra. But pretty standard algebra. Square root of 3 over 2, I got an answer of b as in Beelzebub. Next, I've got question number 22. A few people asked about this one. We haven't done implicit differentiation in a long time, but that's what I see when I see an expression that looks like this, that is mixes of x's and y's. And so implicit differentiation, to remind you, derivative of x squared in terms of x's is just 2x, like it always has been. I'm subtracting this, and this is going to have to be treated as a product. I put a big set of brackets around it, but I've got x times the derivative of y. The derivative of y in terms of x is dy dx, plus the derivative of x times y. The derivative of x is 1 and y is y. And then the derivative of y squared is 2y dy dx. So don't forget about implicit differentiation. After that, I had a couple different ways of doing this. They wanted me to do this at the point 2, 1. So I could have plugged in 2 and 1 in place of x and y, but I thought I would do this in a more general way where we get the actual dy dx. This should hopefully look familiar, even though it's been a long time since we did it. I'm separating my terms with dy dx and my terms without dy dx, so I can factor out the dy dx and then divide. When I did that, I got this for my dy dx, and then I plugged in the value at this time. The value of this derivative at the point 2, 1 is, well, dividing by 0, which does not exist. And I've got two different options for the does not exist. Does not exist, and the tangent line is vertical or horizontal. If it's a horizontal tangent line, that means the derivative is equal to 0. And this derivative is not equal to 0. This derivative does not exist. And so we've got another answer of D as in dominion. And the last question, or at least the last most frequently requested question, this was requested by 5 of you. Which of the following is a solution to a differential equation that looks like this? I don't have a lot of options for this one. The only way I see of doing this is by doing separation of variables. dy dx, I'm going to separate this. I'm going to say that e to the y plus x can be split up to be e to the y times e to the x. That lets me separate my variables. I'll bring my y's over on the left side, bring my x's over on the right side, integrate both sides of this equation. To give myself a more manageable antiderivative, I expressed e to the y as e to the negative y, dividing by e to the y as e to the negative y. That gave me a pretty easy antiderivative. At this point, and after I went through this algebra, you can see it got to be a little bit arduous. Maybe that would have been a good point for me to plug this in. Y of 0 is the opposite of the natural log of 4. And so if I plug in x equals 0 and y equals the negative natural log of 4 right away here at this point, probably could have solved for the value of c and had a little bit easier time. But I didn't recognize that, so I'll let you see what I did here. Antiderivative, and then I'm just solving this for y. So multiply by -1, undo the exponent with the natural log of both sides of the equation, and then do the opposite of the expression. And as I was doing this, I was looking at the answers and seeing that this was looking a lot like the answer choices. Once I had y equals, I then plugged in my initial condition. When x is equal to 0, y is the negative natural log of 4, and then use that to solve for c. In the version that I had, I got c equals 5. If you solved it differently algebraically, you might get c as -5, or maybe you get c as e to the 5 or natural log of 5, or there's certainly different ways of doing this. But I felt pretty good when I got to this, and this was one of the options I had for the answer, I believe. Yes. My answer in this case is C, as in cacophony. And that, I think, is a good place for me to finish. If you didn't see the note, and I'm guessing most of you saw the note already, but the note that I will have for you this morning is going to say, boy, I feel like a time traveler. I'm recording this on Monday afternoon, talking about Tuesday morning in the past tense, but the note I'm going to have is going to be basically, let's move on and do this, a similar thing for the, uh, oh, what am I trying to think of? The calculator allowed section of the multiple choice part. I do think it is useful for us to take a look at problems like these, and I, not surprisingly, haven't gotten a whole lot of input from you guys about things that you would like to do in preparation. If you do have suggestions, if you do have things that you would like to do to help you get ready for the AP test that is looming on the horizon, well, the distant horizon, I suppose, at this point. We still have a few weeks left to do. If there are other things that you guys would like to be doing, certainly let me know. Otherwise, my plan is to do uh, multiple choice calculator allowed today. I'll put a quiz up for you to submit answers again, and then I'll make a video for you to watch on either Wednesday or Thursday. And then we'll start taking a look at some of those free response questions. And that'll hopefully give us a better focus for the AP test. As always, get in touch with me. Let me know if there are things that you want to do, if there are things that you have questions about, or any questions or concerns. Hey, I miss you guys. I hope that this is useful for you, but I'll talk to you some other time. See you. Bye.